So we're back again, and a reminder, if you look below the video, we got links to the chapters for this video, and then we got the big composite index for like 3 years of these videos. And then there's like 3 years ROS agriculture index. And there's probably a couple other things down there. I can never remember what there is. But, if you get a chance, look at that. And then there's also a link to our YouTube page where all these YouTube videos are stored. So all that stuff is down below. And one thing that came up this week was Al was showing his cable that he made up, and he had just soldered some wires onto little header pins. Then when he's all done, he put some hot glue on it. And I'm thinking, I've found various things for making your own cables. And uh, if you go out on Amazon, you can buy, what they call the DuPont jumpers, which are just of course, I don't have one handy here. Here, let me try this. So, the little jumper wires everybody uses, they call them DuPont jumpers for some reason. And it turns out you can buy the single ones like this, or you can go on Amazon and get the ribbon cables, got a bunch of them on there. And then if you want to make your own, if you go out to pololu.com, they got a big selection you can buy. You can buy these in various lengths and various colors, and you can buy them without the housings on. So it's got you tell them what kind of connector you want crimped on each end, and you can go through and piece all those together, decide what you want. Then they got a whole selection of housings to put onto it. So you can get the standard one by one housing like that, or you can get them in 1x2 or 1x5, 1x6. And if you buy it from Polo, you can get all the way up to like 1x12, and then you can get the 2x something. So you can get the 2x2 up through 2x6 are common sizes. Then beyond that, he's got ones that go much greater. You get 2x8s or probably 2x12s. So we were talking about that earlier, that you can piece all this stuff together. And I said I would try to commit to for the meeting next week, kind of go through and we can walk through all that stuff, and I can post links to all those pages. So if you want to build cables that way, you can. So that will be coming up for next week, and I might pre-post some stuff to Slack for anybody that's on Slack or wants to join Slack to see what we talk about. Other than that, I think that's all I've got at the moment. So I will turn it over to Al.
Few things going on here, as Jeff mentioned. I posted out to Slack video of the final some activity to clean up the wiring on my see if I can get to something that's so the IBT has this 2x4. I needed to rewire this because I didn't have 5 volts going into it. I also there's a couple of pins here for tracking the amount of current that's being used. And although I'm not going to spend time figuring that out, I wanted to at least pre-plan for that as far as pen assignments on my Teensy go. So ultimately, I DIY'd 2x4 connector. We'll use the hot glue and a ribbon cable there that's there's more wires than I needed, but anyway, it's an attempt to try to clean up or reduce the hodgepodge on my board. Also spent time on testing a couple of different proximity sensors or induction sensors that measure the presence of metal. This is one that's 8 millimeters. There's another one that I used that was 4 millimeters. I think I like this 8 millimeter one a little bit better, although it's larger. These little indentations allowed me to put strips of wire or ferrous wire to see if it could pick up, what sort of resolution could I get. And the reality is, this is an 8 millimeter induction center. Guess what? Your wire better have a gap of about 8 millimeters in order for it to pick up, was my sort of takeaway. So what that let me do is in Fusion 360, I just mocked up what that might look like for my rear wheel odometry data. So this would be cut out of metal, hole for the axle, 3 holes for mounting some sort of coupler to fasten it to the rear axle, and this gives me about 20 changes or resolution, 20 ticks of resolution per revolution. So that's sort of where I'm heading.
Can you go back to your other picture for a second?
This one?
Yeah, that one. Keep in mind, if you put your sensor on the other side, your sensor would now be up against flat plastic, so you don't have to worry about getting crap stuck in your wires and then getting stuck in between the sensor, if that makes sense.
Mm-hmm. So effectively, you're saying it'll read through plastic.
I assume it will, and it'd be fairly easy to just take your sensor, put it on the other side, and see if it does work by doing that. And then if you go to your, and I don't know how your thing's built, if it's easy to turn that wheel around, or for right now, just take the sensor off and just hold it up next to it. You know, you can even have a sensor rubbing on the back of the plastic if you want. And that way, you know, it'll like scrape off mud and stuff too as the thing runs. So that was something I thought of, that you don't want to, you know, build this and have it picking up all kinds of mud and dirt and grass and stuff in there, and then getting caught between your sensor because it'll snap something off. So that'd be one thing to check. And then if you go back to your other picture, that was your thing you want to cut out. So you take that and then put some kind of plastic. It could be fairly thin. Put a piece of plastic on that, and you might even glue it once you get it on. And that way, the sensor can again look through the plastic and see, it can see the holes. And then again, that eliminates, you know, building up mud and dirt and stuff in there, because you got the sensor would just be rubbing on that flat plastic up against the wheel.
All good things to think about, because you get in the real world, you have grass and other stuff flying up and around that rear wheel.
Yeah. So in a way, you know, just the fact you got something turning, you got the sensor that will tend to scrape it off and keep it clean. But like if you put it up to here, you got holes that's going to collect dirt and crap and stuff. So I think it'd be better to put a piece of flat plastic in between those, just to but just for testing it, you probably don't need that. But once you start, you know, go out in the yard and driving around, that would probably be a good thing to have.
And I didn't mention it, but I'll mention it now. This is, as designed, is 4 inches across. So, you know, it would be relatively small. If I wanted higher resolution, make a bigger disc with the same, you know, separation of teeth, so to speak. So
Yeah.
Anyway, I thought about starting at 4 inches.
And another thing on that, you're talking about getting a hub that's got 3 holes in it. You might just want to consider, I know back when Matt was first doing this, he went out to the farm store and he bought these hubs that, you know, you get one that'll fit on your shaft, and it's got set screws to hold it on. And then basically it was meant to get a sprocket with a standardized hole, and then you're supposed to put the hub into the hole and then weld it into place. And he just used like JB Weld or something, so he just put his sprocket onto this hub, and just you know, you could use super glue or JB Weld or whatever to hold it on there. But I'm just thinking, when you go to make this, keep that in mind, that, you know, rather than getting these 3 holes out there, you have to get a custom hub that's got the 3 holes on it. It might just be quicker and easier to get one of those just off the shelf standardized hubs that just goes through a smooth hole, and then somehow you have to keep it in place. So that's just something else to think about.
Yeah.
Yeah, because it's the rear wheel shaft is 3/4 inch. So yeah, that's a good point. I'll go look at what's a standard looking coupler for a 3/4 inch shaft.
Yeah, they're available at Fleet Farm, and here in Grand Rapids, there's an L&M, which is almost the same thing, and you can get different size hubs with, you can put on different size axles. And then you can put different size sprockets on that hub. And you don't have to weld them. You can just bolt them on or use the set screws.
Roger that.
Another thing to consider there, depending, you have to look at your wheel. Are your back wheels bolted on right now on your lawn tractor, or is it just like a molded wheel that doesn't have any bolts holding it on? And the reason I ask is if your wheel bolts onto a hub already, you might just take the wheel off, put this thing in between the hub and your wheel. So that means the holes here would have to line up with what you have on the hub and the wheel already. You just have to make sure there's, once you put it on, there's room for that to fit without interfering with the wheel.
Yeah, so the axle goes through the transmission. The axle has a thread or there's a screw or a bolt that goes into the end of the axle that keeps the wheel assembly on the axle. So I don't know.
So the whole wheel just slides onto the axle and you just put a bolt at the end so it doesn't fall off.
Yeah.
Okay, so that's not what I was, because the other way is you might have, say, a hub bolted onto your axle, and then the wheel would just have, say, 3 or 4 or 5 or 6 holes, and you'd slide that on and put the nut, kind of like a car wheel works, where you got the lug nuts that hold it on. But yours apparently is not done that way. And I can't think what mine looks like either. So on my mini tractor right here, it's got the hub and then the holes in the wheel.
I don't know why that's got that. So this round piece slides over the axle, and there's a bolt that goes into the center of that
Okay.
holds the wheel onto the axle.
The other thing you can do in that case is you could use the wheel as your mounting plate and just drill your holes through that wheel and then put bolts through, so you've already got, so that basically already gives you a hub on the wheel. So that you might, drill holes into the wheel plate there. And then if you already have holes in the new plate you're making, you might want to put spacers in between to space it out, like 1/4 of an inch or 1/2 an inch or something. But that basically just put that new thing you're creating right onto your wheel before you slide the wheel on, is what I was thinking. Does that make any sense?
A little bit. Let's see what else. Well, I was going to show you some of the code, the proximity sensor. So this was just a simple test to keep track of the number of ticks that were created, but this was the sentence that's worth, or the statement that's worth just mentioning. I mean, it was using an interrupt. So it wasn't like a loop that was running. It was, using the power of the teensy to use an interrupt to detect a change. You can detect an up or a rise or a fall or a change. And so I chose to detect a change. And when it detects that, it executes that function, which basically its purpose is to just keep track of the number of ticks. So if anybody ever wants to test that, there's a little bit of testing code that's out there. It's not very complex, but it's there nonetheless. Let's see what else. So I was messing around with the control steering function of the main program that would run on the teensy, and built out different scenarios or cases and starting to put a PID into the program in order to control my steer angle. At that time, I was using the analog right. This was a week ago. And as Jeff mentioned before, I mean, these are notorious for causing a whine in the motor. So I went out and sort of fought my way through trying to use the other approach, which is this library to generate the PWM. And this is, again, in my repo. Set the frequency. I've used multiple frequencies, so as low as 10,000, as high as 25,000. Seem to be happy with this 25,000, which is what I read is sort of the upper limit of the IBT. And so that's working pretty well. I just happen to have on my board a potentiometer connected to it, so I use the potentiometer to drive the motor forward and reverse at different speeds. So that's why that's on there. And then there's a little bit of a video a little bit later in Slack that walks through the current status of my board, as well as just a short little blip on driving a 12-volt motor that's connected to that. I'm not going to play all that, but the gist of all of that is using that teensy PWM to generate the signal reduces the whine of the motor. Not that I ever hear the whine, because when the tractor's running, the only thing I can hear is the tractor running, but for testing and whatnot, that whine is a little bit annoying. So anyway, getting closer. Oh yeah, well, I should mention also getting closer to being able to test outdoor, because I got my manual e-stop hooked up, and also got my relay hooked up so that when I press the e-stop button on my radio control, the signal comes through to this relay to ground out the ignition wire. So getting closer and closer to getting back out to do field testing is the bottom line. That's it for me. So the next step is,
I have a couple comments on your video that you're just doing there. Number one, get yourself a plastic pointer instead of using a screwdriver to do that.
I think that's a safety moment, Bob.
And you're getting ready to put me in another rant here, because I watch other people's videos and they'll use metal tweezers and they'll be poking at their board while the thing's running, you know, taking the jumpers on and off by using metal tweezers. And just don't do that kind of stuff, especially on this where you got enough power there. If you poking that screwdriver around, you're gonna have a big bang. It's not as exciting as your battery terminals like we talked about last week, but you know, you might consider that. Or the guy with the Swiss accent, he's got a pointer that's a little piece of plastic strip, and he's got a picture of his gloved hand on the end of it glued to
I've
it.
seen that. Yeah, I remember that.
He pokes, he points at his stuff, so it's like taking his hand into him. He's got a little miniature hand that he's using as a pointer. The other thing was, you keep referring to that relay board as a USB relay board. As far as I know, there's no USB about that board.
There's not. I have a USB board, a proper USB board, but this one isn't. This is GPIO pins.
But I think you know, at least twice in the video you kept calling it a USB relay board. So I just thought I'd mention that.
Thank you.
I thought there was one other thing on this, but I can't remember what it was now. That's all I got on that, I guess.
That's all I got too.
So Bob, you got anything?
Yeah, I changed things around on a small robot, switched the battery places, and I'm trying to mount as much stuff on the batteries themselves to free up the footprint. I did get that remote control for a stop switch works pretty good. Then I put a hold on the motor control, and I'm looking at doing computer vision. So I found 2 links from, what's this guy's name? Alexander Abar. And he's working with a Raspberry Pi 5. Got through the first tutorial, and I got she's working, and it looks nice. The video, I noticed that the video on my end is in real time. There's no delay. I started on his second video where he loads. He'll be loading Visual Studio for editing, and that's where I'm at now. Is I'm halfway through that second one. I'm taking a pause, and now I'm learning this Visual Studio. I've got some things up on the screen, and it's kind of crude. I'll try and use the iPad to turn around and show you, but I've only got one hand, so it might be a little jumpy. So I don't know if you can. So there you can see the camera, and I notice with all the terminal windows open, there's quite a bit of delay as I move the camera. And let's see, I'll go ahead and switch over to click on the. Now I'm starting on learning a Visual Studio. Let's see, there we go. So I kind of hope to finish this up in a day or two, and I'll complete his 3 videos and see how that goes. But that's about where I'm at right now.
If you think about it, Bob, post the tutorial that you're going through on the camera and the RPi. It might be interesting to see that.
Okay. I think I've got them on Slack, but we'll probably have to put them on the video.
Oh, if they're on Slack, that's cool.
Yeah.
I can copy them from Slack and put it into our description for this video.
Okay. Yeah, I got the 2 links. I don't have the third one that talks about studio code, but I'll post that when I get going and I'm more familiar with it. And that's all I got.
Okay. Al, anything else?
No, I'm good, thanks.
I don't think I have anything else. So usually, but I get to this point and I think, oh, somebody said something. I'll go back and talk about it. Right. Offhand, I can't think of those words. So
yeah,
I'm going to go ahead and stop the recording.